Hey guys, listen, I'm sorry I couldn't be there again today. Just can't shake this thing, and got something to do. I have to get done this afternoon, so I apologize. No matter what, I feel like tomorrow I'm coming on Thursday. We're going to review everything really good, get you ready for Friday right before spring break. All right, I'm going to show you one of each type of problem you're going to have to do, so that hopefully you're good to go. Hopefully watch a video or two. The first set says, given the polynomial has the given zero, find the other ones. They're going to tell you, I'm going to do 43 for you. They're going to tell you what one of the zeros is. It's -5. So put the -5 in the box. You better get 0 when you work this out. So bring the 1 down, multiply, add, multiply, add, multiply, and sure enough, you get 0. What they want you to do is find the other zeros, which means you're going to take what you have left down here and write it out. There's x squared because I start with x cubed. There's no x. There's a -2 equals 0. Just move that 2 to the other side. Take the square root of both sides, and you get plus or minus square root of 2. So the zeros are plus or minus square root of 2. And don't forget the -5 you started with. And there you go. So for 43, the first set there, through whatever, that's what you're going to do. Put the number they gave you in the box. It's going to work. And then do what you need to do to solve that. You may need to do quadratic formula. You may need to factor, complete the square, whatever. Do what you need to do. Okay, 49 to 50, whatever. It says list all the possible. So you don't have to solve these. The way you make your list is you take let me see which one's the hardest. I'm going to take 51 because it looks the worst. You take the factors of the last number, the 8, which are the factors are 1, 2, 4, and 8. And the factors of the first number, which is 1 and 2. And you put all of these factors, the 1, 2, 4, 8, over all of those factors. So all the factors of the last number over all the factors of the first number. So I'm going to put them over 1, 1 over 1, 2 over 1, 4 over 1, 8 over 1. So I put all these over that 1 first. Notice I didn't write the 1. There's no need to put anything to write something over 1. So it's left it that way. Now I'm going to put them over 2. Okay, so I'm going to put 1 over 2. I could put 2 over 2 if I want to, but 2 over 2 is really 1. I could put 4 over 2 if I want to, but that's really 2. I could put 8 over 4 if I want to, but that's already up there also. So it's already 8 over 2, which is really 4. So really and truly, that's the list. Now what that gives me is those are the numbers that in a second I'm going to use to find out what the 0 is when they don't tell me what a 0 is. Like what the answers are. Well, one of these or 2 of these or whatever are going to solve this thing. And we're going to find out on the calculator here in just a sec. And this is the sec. Okay, so it says for each of these, find the rational zeros and the other zeros that solve it. Factor into linear factors. Okay, so I'll just do the first one, 55. I'm going to start off by making a list. This is not a bad list. The last number is 6, the first number is 1. If I put the factors of 6 over 1, be 1 over 1, 2 over 1, 3 over 1, 6 over 1. So those are what I'm looking for. So what I'm going to do is I'm going to punch this right here in my calculator on y equals. I'm going to graph it and see if it crosses the x-axis or it has an x-intercept, which is, by the way, the same thing as a 0 at one of those points. I'm going to go graph that right now. All right, when I did that, it looks like it crosses at -3. So I'm going to try, and remember, you got to prove it. So I'm going to try to, plus I got to break this down. So you really have to do this. 1, 3, -2, -6. Bring the 1 down, multiply. Should get a 0 if it works. 0, multiply, it's still 0. Bring that down, yep, +6. I can't believe this. I got the same thing I got a minute ago. I started with x cubed. And remember, I'm trying to find all the zeros. So I'm going to bring down the x squared. There's no x. -2 equals 0. Solve that. Again, solve this just by moving the 2 over. Take the square root of both sides. You get plus or minus square root of 2. So the zeros are, I'll just come in here, plus or minus square root of 2. And don't forget the one we started with, -3. Those are all the zeros. Now, it also said do something else. It said factor and linear factor. So take your zeros down here and do what we did yesterday. Take the -3, write x plus 3. Take the negative square root of 2, x plus the square root of 2. Take the the positive square root of 2, x minus square root of 2. So there's the factors, there's the zeros. One more problem. All right, this is going to be kind of weird. The Descartes' rule of signs gives you how many positives and how many negative zeros there are. Sorry. I'll show you 51 real quick. Not difficult at all, but you're just not used to doing stuff like this. So back in the day, this was extremely important. To be honest with you, now that you have calculators, it's not quite as useful as it used to be. but still, they want you to know it. So here's the deal. The number of positive real zeros is the same as the number of sign changes. So I'm going to count how many times the sign changes positive. Here, it changes the negative, changes back to positive, changes back to negative. So there are 3 sign changes there, so I'm going to put 3. Now, it's not just how many sign changes there are. It's how many sign changes there are or less than that by an even number. So what we're going to do is we're going to subtract 2. That means there's 3 or 1 positive answers or positive zeros of that function right there. 3 or 1. All right, now if I'd have gotten 4, I'd go 4 or 2 or 0. You keep on subtracting 2 until you get down to 1 or 0. Now here's how you find the negative ones. The negative ones, you really plug in a negative x. I'm just going to give you a shortcut here. That means the signs on the odd exponents change. So if I'm looking back at 51, the x to the 5th is odd, it changes. The x squared is even, it stays. The x to the first power is odd, it changes. The negative, you never change the sign on the last number. So those are all negative, which means there are no sign changes at all, which means there's going to be 0 negative. You don't subtract 2 from that because you're already at 0. So it should make sense. I could have 3 positive and no negative, which makes sense because, well, I could have that, or I could have 1 positive and no negative. Okay, and that's really useful because if I'm looking for that first one to see if it works, I'm not going to even look at the negative side because there are no negative answers to that one. Okay, no negative rationals, I should say. So, or real ones. All right, hope that helps. I hope you do well today. I will be there tomorrow no matter what, and we will get you completely ready for Friday and ready to get you to spring break. Hang in there. I'm trying to hang in there. All right, I'm sorry. I've never missed. I can't believe I missed twice, and it is what it is. Sorry about that. See you tomorrow.